Hello everyone, welcome to our channel. It's all about education. Today we'll be learning programming in C++, chapter 2, data types. Let's begin with the chapter data type. So first definition we come across in this chapter is data type. So what is a data type? It indicates the type of the data the variable can hold. So what does this statement mean? So we all know that a variable is used to hold the data, right? Whenever you are using some variable in a program, you mainly use it for storing the data. So who should indicate what type of data the variable can hold? That is nothing but data type. So data type, what it does, all it does is it will indicate the variable, or it will instruct the variable that the variable can hold only this sort of data. You'll have, whenever you're working out on a program, you'll have numerical values as well as characters to work on. So the type of the data that the variable should hold according to your program and according to your needs, that is nothing but data type. So what it does, it will indicate the variable to hold only this particular type of data. We have many types of data types which I will be teaching now. Let's move on to the next one. So coming to classification of data types. So data types are broadly or mainly classified into three types, that is fundamental data types, basic data types, built-in data types. All these three are same, please don't be confused with them. So basic data types, so we have three types. They are basic data types, derived data types, and user defined data types. First, coming to basic or fundamental data types. What are these? So these are the primary data types which are not composed of any data types. So what does this sentence mean? We know that suppose let us take the example of colors. If you take the concept of colors, you have primary colors, secondary colors, and many colors. So out of these many colors, the most basic ones or the most important ones, the most basic ones or the fundamental ones are your primary colors, right? So with those colors you can form secondary colors or many other different types of colors. So the same way, if we take C++ data types, we have the most basic ones that are int, float, char, void. These are all nothing but primary data types, means which are these are the basic elements. If you want, we can take another example like sugarcane, right? Sugar. So sugar is the derived product there. Sugarcane is the basic one. So if you want to produce the sugar, if you want to produce some sugar, first you will need to have what? Sugarcane. From sugarcane you will be deriving what? Sugar. So what is my sugarcane here? It is the fundamental data type. Hope you understood the concept. Now coming to these examples like int, float, character, void, I'll be teaching you all of these in detail in this video. Okay. So the examples include int, float, char, void, and boolean. Next, coming to derived data types. So what are derived data types? They are created using built-in data types. So let us take the same example of your colors or sugar. So what happens when I am making sugar? I'll need sugar cane first. So I'll use sugar cane in order to produce what? Sugar. So what is my sugar here? It is nothing but derived data type. The derived product is sugar. That is nothing but your derived data type. So arrays, they are made from int, float. You can take any data type, but you are creating another data type through it, through the basic or the fundamental ones. That is nothing but your derived data type. Fundamental data type is your sugarcane. Now I am telling this for your understanding, so please understand the concept. Sugarcane is the basic one, it is the initial product, and sugar is my final product, that is nothing but derived product. So if we take it in terms of data types, fundamental ones are int, float, character, char, void. Using these data types, you will derive some other data types. Those are nothing but derived data types. For example, arrays, functions, pointers, right? So same. The examples include arrays, functions and pointers. Next, coming to user defined data types. So user defined data types are the data types which the user is going to create according to his needs, right? According to the user needs. If you are creating your own data type, that is nothing but user defined data type. So let us read out the definition. They are created using both fundamental and derived data types, right? Using fundamental and derived data types, I can create my own data type according to the problem or the program I am working on, right? So that is nothing but user defined data type. Examples are like structure, union, class, enumerated. We'll be learning structure and class in detail. So at present, let us know the basics, right? So user defined data types, examples include structure, union, class, enumerated. Next, it will be helpful if you memorize the chart, or it's okay if you want to refer this. It's quite easier to actually divide them, classify them and learn. Always try to remember the concepts in a diagrammatic way so that it would be helpful to you. Next, coming to the basic data types. Now we know what are the basic data types, right? They are the primary data types which are not composed of any data types, means which they are the most basic ones. Using those we can derive other data types, or we can create our own data types, right? So here we have the examples are int, float, char, void, boolean, right? I'll be explaining all of these data types in this video itself. So first let us learn the concept of modifiers first, because we'll be using it here. When you come to modifiers, see, let us make this very simple. Modifiers are nothing but, suppose you are writing a program. You are allocating, I have taught you the structure of C++, right? The structure of C++ program. There, one of the important stages you find is initialization of a variable. So whenever you are creating a program, you tend to initialize a value, initialize a variable to some value. So for that, whenever you are storing, or whenever you are creating, or initialization, or whatever it is, you are creating a variable in the program. That means you are creating the memory space. You are creating the memory space. You are allocating the memory in the compiler so that you whenever you are working on your program, it can store the value or it can display the value. So in order to do that, we'll need some memory space. Suppose if you take your integer data type here, it will always allocate 2 bytes, no matter how much ever variables you take. You might take 5 variables, 10 variables, or despite of the amount of variables you take, it will always allocate 2 bytes for every variable. So if you want to alter that, if you want to change the size according to your need, you can't change it however you want. But if you want, if it is a large number, or depending on the size of the data you give, you can actually alter the size of the int. So that is done using modifiers. So let us read the definition now. It is used to improve the accuracy of value and memory spaces according to the user need. As I said, you can improve the accuracy of a value, as well as you can also alter the memory space according to your need. So I'll tell you how to do that. So whenever you come for integer data type, no matter what the number of variables you declare, it will always allocate 2 bytes for every variable. So here whenever you take integer, it will always allocate 2 bytes for every variable. Suppose you have a very large number, but integer allocates only, int data type allocates only 2 bytes. So what do you do in such sort of cases? So short int is used when you're value is very small and using 2 bytes would be a waste. What do you do then? You go for short int. So what does the short int do? Whenever you will allocate any whenever you declare any variable under short int, it will always allocate 1 byte. So what happens if you are giving a small number, extremely small number, then you can use short int, so that you can actually save the data there or the memory space. See, initially it will irrespective of the number of variables you give, it will always allocate 2 whenever 2 bytes whenever you declare it in integer data type. But if you want 1 byte, if the value is very small and you just want 1 byte for it, if you want to allocate only 1 byte, then you can opt for short int. But what do you do if your value is so large and 2 bytes are too less for it? Then what do? You opt for long int. So what does long int do? It will allocate 4 bytes. So whenever you declare any variable under long int, it will always allocate 4 bytes. So if you want 1 byte, then you can opt for short int. If you want large number, you want to declare a large number, you want to input large number, then you can go for long int. Now next, coming to float. So what is my float? It is a decimal value. So whenever you want to give any decimal value in your program, then you opt for float. It will usually allocate 4 bytes. I'll be explaining all this integer, float, char, void, everything I'll be explaining you in detail. For now, just know the memory allocation, how many bytes does it allocate, right? So whenever you're declaring any variable in float data type, how much bytes does it allocate? 4 bytes. How many bytes? It is 4 bytes. But if you have if you want more memory allocation for it, more memory space, then you opt for double. Whenever you declare a variable in double, it will allocate 8 bytes in total. It will allocate 8 bytes if it is double. For float, it will allocate 4 bytes. But if you have more larger value, right, if you have more larger value, even 8 bytes are not sufficient, then you can opt for long double. That is nothing but it will allocate 10 bytes of memory, right? It will allocate 10 bytes of memory space. So you can opt for long double. So float, it will allocate how many bytes? 4 bytes. Double, 8 bytes, and your long double is 10 bytes. Next, coming to character data type. So whenever you declare, here you need to learn a major difference between char and string. Whenever you are using char, it will allocate only 1 byte of memory, 1 byte, and it will only display 1 character at a time. You can either input a single character at a time, or you can output a single character at a time. You can't, if you want your name to be printed on the screen, you can't use char data type. You will have to go for string. Strings, again I'll be explaining you strings in a separate video. So whenever you are choosing char, make sure you are using it only for a single character. Char works only for a single character. You can't use it for your whole sentence or name. Next, coming to void, it is 0 bytes. I'll explain you why. I'll explain you about void. That time you'll come to know why it is 0. And next, coming to boolean, it is for logical expressions. It is usually used if you study further, you'll be having boolean algebra and all. So whenever you are working with boolean, it's always about the result, if it is true or false. So let us learn all these one by one now. Yes, coming to the basic data types, the first basic data type is int. So it is used to accept only whole numbers. The whole numbers, full stop should come here, right? The whole numbers can be either positive or negative numbers. So whenever you are using int, make sure that you give only whole numbers. Suppose you are giving the pi value there, but you have declared the you have declared the variable under int. So what does it happen whenever you are giving the input as 3.14? It won't accept 3.14. It won't accept the whole character or whole number. It will only give you the output as 3. It won't consider the decimals. So int is used, it is only used for whole numbers. You can't give decimal numbers in it. And the whole numbers can either be positive or negative, it's your wish. But you can't give decimal numbers, because even if you give decimal numbers, it will only consider the whole number in it, whole part in it. And the keyword is int. The memory space is 2 bytes. Now 1 byte is equal to, this is an important conversion you'll need to know. So 1 byte is equal to 8 bits. This is very important, because for if you want to convert bytes into bits, this becomes very important. So 1 byte is equal to 8 bits. Here 2 bytes are there, so it is 16 bits. For your convenience, I have given the bitwise memory space also here, like in bits how much it is. But if you want to calculate it for any other memory spaces, whenever you are converting bytes into bits, this becomes very important. So 1 byte, always remember 1 byte is equal to 8 bits. Understood? So 2 bytes are equal to 16 bits. So please remember this. It might help you anywhere whenever you are converting bytes into bits. So 1 byte is equal to 8 bits. It's a must. Please remember it. Next, memory range. As I told you, you can either opt for negative numbers or positive numbers. Within this range, you can give any sort of values under int. Right? Next, under int again, as I have told you, you have short int as well as long int. So under short int, what happens? It is used to represent small integer values. I have told you already. So whenever you are declaring small integer numbers where 2 bytes is more, you can opt for short int, while it allocates only 1 byte. So whenever you are having small integer values, opt for short int. You can declare it under int or you can declare it under short int. But you are very precise about the memory, then you can go for it. You can go for short int. The keyword used is short int, and then this is the memory range. Till here you can actually declare the values under short int. It will declare only 1 byte. Again, I have told you 1 byte is equal to 8 bits. So please remember this value. Next, coming to long int, it is used to represent long integer values. You have very long integer numbers, then you can opt for long int. It will allocate 4 bytes and the keyword used is long. You'll have to just declare it like long a semicolon. Right? You know the initialization. I'll tell you that. I'll tell you how to declare the variables. So long int, it is used to represent what? Long integer numbers. The keyword is long and the memory space is 4 bytes. Next, coming to float. Float, it is used to represent a number with a decimal point. Any decimal numbers you have, all of them come under this category known as float. So you can have both positive as well as negative numbers in it. It's your wish, but it is used to accept decimal point. You can give integers also, but like, why do you waste the memory space when you already have int? So if you have any decimal numbers, opt for float. Otherwise, you can go back for int itself. It will always allocate 4 bytes and the keyword is float. Next, float again has 2 modifiers, that is double and long double. So I told you, double, it is used to represent large float values. If you have large float values, then you can opt for double. The keyword is double and it will always allocate 8 bytes. So how it is 64 bits? 8 into 8, right? 1 byte is equal to 8 bits. Sorry, 1 byte is equal to 8 bits. So 8 into 8, 64. So that is how you got your 64 bits. So it always allocates 8 bytes, that is 64 bits. If you have very large values, if you have very large float values, to be precise, you can always opt for double. You have more larger values, you have to allocate so much, then you can opt for long double. Even if double is not sufficient for you, you can opt for long double. It is used to represent largest float numbers. The keyword used is long double and the memory space is 10 bytes. How it is 80 bits again? 10 into 8. Hope you know the basic maths. It is very simple. 1 byte is 1 byte is 8 bits. So 10 bytes are equal to 80 bits. Right? So this is the memory space, and it is all about float. Now next, coming to character data type. Char is the keyword for this. So as I told you, it is used to represent single. It can either be special character or digit. It is character or digit at a time. You can use it to display or input for only single character. You can use only single character if you are using this char data type. The keyword is char and the memory space is 1 byte. Right, next, void. So void, I told you, it will the memory space is 0 bytes for it. Why? Because it is an empty set of value. It is an empty set of value. It means whenever you are using, actually this is this return, right? Sorry. So this is return. Please correct it here. It's a typing mistake. So it is used to represent an empty set of value. Whenever you are using void, it is used to what? It is used for an empty set of value. So whenever you are working on your C++ programs, one of the important sections in this structure of C++, you could have seen void main. So you use void main, function is there, right? Void main. So whenever you are using void there, it will not return any value to the main program again. It might be either used for void, or whenever you are learning the functions, you will understand the importance of void. So whenever you are using the functions, you want to return some value, then you instead of void, you write the data type there, what sort of output you are getting. If you want to return that to the main program, then you use the particular data type there. Or if you don't want to return any value to the main program again, then you will be using this void. So it allocates 0 memory space and the keyword is void. So whenever you want to represent an empty set of value, you use this void data type. Next, coming to Boolean type, as I have told you, it is used to represent logical values, that is either true or false. Whenever you are working with Boolean algebra or logic gates, mainly you will come across this concept, that is Boolean data type. So whenever you are giving a statement, or if you take the example of logic gates, if both the input for AND gate, if both the inputs are true, then the output is true, right? So the same way, whenever you have to get output in terms of true or false, then you use this Boolean data type. The keyword used for it is bool. Next, coming to user defined data types. Actually, enumerated data types, they are not used much here, and I won't be explaining this enumerated data types anywhere else. I'll be just briefing the concept here. So just have a rough sketch of it here. So before that, I'll be teaching you initialization of a variable. So first, if you learn the initialization of a variable, then it will be easier to learn the data types. Actually, this concept should be taught in the first chapter, but I have missed it there, so I'm bringing it here. Initialization of a variable, it is very, very simple. So whenever you are declaring something, suppose you take the example of int a, right? Suppose I am declaring an variable under int. My variable name is a, semicolon is a must. Whenever you are ending this statement, please remember semicolon is very important. And sorry for the bad handwriting. If you understand, it's enough. So whenever you are declaring something under a data type, you can either declare like this, and you can ask the user to actually input the value of A. That is your next chapter. How do you give the input and how do you take the output? So for now, learn this. So you can either ask the user to give the value during the runtime. Otherwise, you can initialize the value of a variable inside the program itself. So how do you do that? Syntax is here. I'll always strongly suggest you to learn syntax and example together, because whenever you learn this syntax and example together, you can actually compare and see how it is matching. Then you will understand how you can actually declare. So here, what is my int? It is nothing but data type, right? Int is nothing but my data type. What is my variable? This one. Suppose I want to declare the value. In the program itself. Then what do? I'll simply use assignment operator. This is nothing but assignment operator. So I'll use the assignment operator and I'll give the value here itself. So example is data type int. Here we have. Then variable we have A, and this is our assignment operator is equal to is nothing but assignment operator. So if you want to equate two things, suppose you are equating two things in your program, you have to use is equal to symbol twice. When you use this symbol twice, then you are comparing two values to check if they are equal or not. If you are trying to initialize something, then you use only single equal to operator. Please remember this, it is important, because most of the students, most of them get confused here. They think whenever you use a single is equal to operator, they think it's comparing the values, but it's actually not comparing the values. Whenever you use single is equal to operator, you are actually initializing the value. So please understand that. So whenever you are using this and you are declaring the value here itself, that is nothing but initialization of a variable. So, and always remember another important concept: initialization is always done from right to left. It is never initialization can never happen from left to right. It means I am putting 5 in A. I am not putting A in 5. I can't take a variable and put it in a constant. I am always taking a constant and putting it in a variable. That is nothing but your initialization. See, here always the initialization happens from right to left. It can never happen from left to right. Please remember this concept, because whenever you will be learning the operators, there are very high chances that you will be mistaken there. So it will always happen from right to left. That means I am initializing, I am putting 5 in A. I am not putting A in 5. I am putting 5 in A. So hope you understood this concept. So initialization, it is very easy concept. You are just declaring the value inside the program itself. Instead of using another cout statement, cin statement, you will directly declare it under the program itself. That is nothing but initialization of a variable. It is quite helpful when you work with some problems. I'll be teaching you those problems too. So for now, understand this is the initialization of a variable. This is how it should be done. Now coming to enumerated data types. So what are enumerated data types? They are used to assign constant values to the variable. Whenever you want to assign the constant values to the variables with constant difference, then you use this enumerated data type. The value assigned will be of an integer type. This is important, you will have to note this. So whenever you want to assign constant values to the variables, what do you use? You use enumerated data type. The keyword used is enum, and here we have syntax and example. Compare them and learn so that you will understand them better. So here keyword used is enum. Enum is there here. It is there here also. Then tag name. What is my tag name here? N. It need not be in square bracket always, you are just declaring it, that's all. Tag name, what is my tag name? N. And what is this? Enum list. Under the flower bracket you will be giving the enum list. I'm sorry for the bad handwriting, I really can't write well here. So enum list under the flower bracket, inside the flower bracket. So suppose your just now I have taught you initialization, right? A is equal to, here I am declaring A is equal to 5. So what should be my output here? So I have told you, enum, what does it do? It will assign the constant values to the variable. So constant values with constant difference I have told you. So if my enum for this statement, what will be my output? Here I'll be writing the output here. A is equal to 5. I have given A is equal to 5. I'm declaring it inside itself. Next, which is the next value after 5? I told you it is used to assign constant values. With constant difference I have told you. So it will be 6. Then 7. So you might get a doubt. How can you say, ma'am, that the constant difference is 1 only? Because the compiler, if this note is important actually. If you don't assign any value, if the user does not assign any value, then the compiler will automatically assign the value from 0, 1, 2, 3. See, here you can see this is not a mathematics class, but still you will have the idea of an AP, right? Constant difference you will have. So common difference is same. So here 0, 1, 2, 3, just the series of numbers. 0, 1, 2, 3. Here I have declared this A, that is starting point. Starting point I have declared it as 5. So I will be having 6 and 7 here. If I declare it as 4, I will have 5, 6. So continuously with constant difference, constant values. That is nothing but your enumerated data type. So it will, if you don't assign any value, suppose if it is like this, A, B, C, you didn't declare anything here, you have just given A, B, C. Then what does my output become here? What does my output become? 0, 1, 2. Right? This will be my output. But if I assign the value, if I give A as 5, then what do I get? 5, 6, 7. So this is all about your enumerated data types. And initialization of a variable I have already taught you. So hope you understood the concepts. If you have any doubts, please make sure that you comment it in the comment section. I'll be answering your doubts there. Thanks for listening the lecture. Thank you all. Please consider subscribing our channel and liking it. Thank you. Meet you all in the next session.